Well, hey there, everybody. We've made it till the last lesson. This is Chem 127, lesson 14. Again, starting up there with a little bit of hot weather related music. If you know the Allman Brothers Band, maybe you'll recognize that. If not, you should definitely raid your parents' record collection and get a copy of Live at Fillmore East. Anyhow, uh, this is sort of a supplementary lesson in that the first time I did this course, it went through 13 lessons and it stopped at the so-called AR4 report. Here we're going to talk about the updated scientific case for anthropogenic climate change. Invariably, a lot of this will be repetitive uh, because a lot of this, when the 2007 report came out, I mean, the press releases were like, "Oh, the scientists have all agreed global warming is real, and the case is over, and now it's time to do something about it." And well, and then the media and society changed its mind as to whether the case was settled or not, and they're going to keep doing this no matter what anybody thinks about it. And there have been some updates to the science. The downside is that things have gotten a lot more complex. Uh, uh, and I think the AR4 really spells it out in simple terms. Now it's spelling it out with a fair degree of more complexity, which I think even makes the summary for policymakers rather difficult to read. So we're going to go through that. That's why I had you read both, saying I think that the AR4 is a little bit easier to digest, but I think there's an obligation to have the most recent snapshot of the science on an issue like this. So we'll try to do a little bit of both, and hopefully this does seem a little bit repetitive. And I'm going to go through and make that case again that I want you to regurgitate for your final essay. So maybe there's another sort of primer code or a finish code on that. Here we go. We got to go here for that. Oops. There we go. Sorry about that. So here's how we frame this case, right? We've got, if we want to prove this hypothesis, if humans are affecting factors that affect the climate or affecting climate forcing agents, greenhouse gases, then that will change the temperature. For this to be true, the temperature's got to be increasing. Humans have to be doing something. So for us to sort of make a logical connection between these two things, the first thing, those two things need to be true. And then we need to find mechanistic evidence for a relationship. And again, I'll talk about both mechanistic data and empirical data. We've seen even from the Vostok ice core that, temperature and things like greenhouse gases tend to correlate. They tend to track each other. But that's not necessarily mechanistic evidence. That's what a scientist would call empirical evidence. The mechanistic evidence comes from the models, among other things. So let's go forth here. So for the first part of this, global average temperature needs to be changing. T needs to be true. There's a lot of this evidence besides the temperature measurements, direct land, air, and there's a lot of update in the AR5 on ocean temperatures, and they cast this in terms of ocean heat content, and they make a big deal out of it. But there's also been changes in ice cover, snow cover, sea level, weather patterns, and let's just take a quick view of this. Here's the bottom line statement. Warming of the climate system is unequivocal, and since the 1950s, many of the observed changes are unprecedented in decades to millennia, okay? Which means the climate's changing, and it's been changing pretty dang fast in the last 60 years, 65 years even. Snow and ice have diminished, sea levels risen. Okay, so there's lots of observations there. Ocean and atmosphere have warmed. And again, they really put a lot of emphasis on the ocean because scientists are starting to realize that a lot of this heat that's been trapped has been stored in the ocean. Water holds heat very well. It's got a high heat capacity. So that's where a lot of the global warming is. Okay, air temperatures, we've seen this data, the rise from, say, the mid-teens to about 1945, a leveling off, and then a warming trend. One of the things that you will hear skeptics talk about is saying, hey, look, global warming stopped. There hasn't been any warming in 18 years because this data has maybe leveled out a little bit for the short term. It's leveled out with, 9 of the last 10 years, the warmest on record, and so on and so forth. And these are really warm years. I personally don't take that as means to say that global warming has stopped. We can see that there's a lot of chaos in this, and we're talking about a long-term background trend. But you'll see that on billboards paid for by people that I think are dishonest people trying to tell you that global warming is a joke. But they stopped the data right there, and they started the data right there, and they had actually addressed that in this report, for better or for worse. I'm kind of disappointed that that these reputable climate scientists are getting jerked around by people like that. In terms of decade averages, so if you take this chaos and try to average it out 10 years at a time, you can see these warming periods. And again, this warming period since the mid-70s is pretty remarkable. Here's what this looks like over the last 112 years as a color-coded, and you can see, Northern Europe and the Arctic and the Amazon have gotten much hotter. And there's limited data. So there's not global coverage here for the last 112 years. But that kind of shows you that the patterns are uneven, and there's a couple places, southern United States and sort of, upper mid-Atlantic, that have actually gotten cooler over the same time period. So this has not been a uniform thing. I've got that little spirally wheel. There we go. And then, there we go. Here's the text. Okay. So we've seen a warming of a linear trend of 8.5 degrees C. There's no denominator there. 0.85 degrees C for the period 8. That must be per decade. I must have deleted that by mistake. That's definitely per decade. And I'm going to have to check that, damn it. Okay, the text. Total warming at this point from 1880 to 2012, 0.85 degrees C. Okay, that number keeps growing a little bit as the window opens up. It says almost the entire globe has experienced surface warming, except for those things that I point out. And it's virtually certain. Now, again, this IPCC report sort of qualified the language. Basically, the troposphere is warmer, and there's 90+ percent confidence in that. Okay, sea level. Okay, this is the thing that they're doing now here from about 1950 forward, is talking about ocean heat content rather than ocean temperature. And I think that is that the temperature is widely varying from place to place. There's ice floating in the Arctic, and I think rather than they've been sort of summing the total heat content so they can better illustrate the amount of heat that's going into it. But the downside is that this data only goes back to about 1850, and it gets pretty wobbly back in here, but you can see that we're converging as we go forward here. And again, sea levels come up by the better part of 20 centimeters, which does not seem a lot, and these various measurements are all consistent about it. So one of the things to look at with this stuff is there's multiple sets of data here that are in agreement, and that's always a good thing when you're dealing with scientific data. Let's do this. Just closing some things on my computer here. Okay. Rate of sea level rise since the mid-19th century has been larger than the mean rate during the previous millennia. So we're seeing this acceleration in sea level rise. Interesting. The biggest single factor here is still ocean thermal expansion, about 1 millimeter per year. But if you combine mountain glaciers and the Greenland ice sheet, they're about an equal amount. So in the AR4, I told you that thermal expansion of the ocean, just the water getting warmer and expanding, was the biggest deal. Melting ice is starting to equalize that, so on and so forth. Okay, Northern Hemisphere snow cover. This is kind of maybe a sketchy trend, but sort of amidst the noise here, we can see that snow cover in the Northern Hemisphere is starting to have a detectable decrease. And summer sea ice extent is going way down. The Arctic is going to be ice-free every summer here in a few more years. And in fact, they've started shipping some shipments around the top of North America, which is saving money and cutting fossil fuel emissions. But that used to be a lot harder. You had to go around South America or through the Panama Canal. That's just kind of a significant conceptual change, I think. Okay. Greenland and the Antarctic ice sheets have been losing mass. Glaciers are melting worldwide. All these things. Okay. So it's very high confidence that snow cover has decreased since the mid-20th century. So in spite of that graph, and they're pretty confident that it's decreased. Maybe it hasn't decreased a lot, right? And they're just saying that it's high confidence that it has decreased. Permafrost temperatures, high confidence that they've increased. So our Russian hockey player friend, his work is making it in here. That's pretty cool. Substantial Arctic warming, and we've seen in our reading that the Arctic is roasting, and that's substantiated here by what the scientific summary is giving us. Weather, precipitation patterns are changing. Here in Wisconsin and most of North America, we've been wetter over the last 110 years. If you look at, say, 1951 to 2010, you're starting to see some drought creep in Mexico and the western United States here, and Africa and the Mediterranean and China. Precipitation has been decreasing. One of the things you might notice here in Wisconsin is that we've been getting more of this in large precipitation events. The past few summers relative to this one, it's been really wet until about the 1st of July, and then it's really dried out. And this summer, which is 2014 when I'm currently speaking, seems like it's going to stay rather moist, and that's nice because I don't like to haul the hose around to keep the garden wet. And then here's a big chart that I just want to call attention to. And again, you'll notice that there's likely, very likely. These things are all qualified, and I will show you together, as is when they say medium confidence, high confidence. These are all calibrated lingo, like when they say, virtually certain, that's greater than 90%. Likely, that's like greater than 50%. Very likely is like greater than 70%, and those percentages might be wrong. But some people say, well, geez, they use all this vague language. It's not vague language. It's actually, and I'll show you this chart here in a second that says when they mean that, they're actually putting a percentage estimate on it. But I mean, what are the things they're looking at? Warmer and fewer cold days, warmer and more frequent hot days, heat waves, heavy precipitation events. Okay, likely medium confidence. So these are these ideas where we get these major downpours, and I think we've seen them the last few years in Wisconsin, and it'll take another 10 years of consistency to say whether that's really a persistent change in the weather or whether it's just a blip at this point in the time. Intensity and duration of drought. So we're starting to see some indications of extremes here. Increases in hurricanes, low confidence in this. This might be a change since the AR4, where there were some studies where they were saying, I think we're seeing more hurricanes and things like this. Maybe they're backing off on this a little bit. Extreme sea level, likely, very likely that it's going to, and this far right column is the future, where they say, essentially what this says is that, they don't know much about the early 20th century, but they expect this stuff to be coming forward. Okay, and again, this is what this means: virtually certain, 99%, very likely, blah blah blah, unlikely, exceptionally unlikely. So this looks like vague language, but it's all, there is a likelihood scale. Again, because this is very, very guarded language, and they know that there's going to be criticism coming from people that don't want to hear this stuff. So they're very careful to make sure that their case is as firm as possible. And I think they show a fair degree of honesty about, the stuff they do know and the stuff they don't know. Okay. I think the end result here, again, is that even after the AR4, we can still say the T, or AR5, the T is still true.